Hello everyone. Today we're gonna solve a problem on circuits by analyzing a network of resistors shown in this figure. Let's get started by reading the question together. In the figure, R1 is equals to 1 ohm, R2 equals 2 ohm, R3 equals 3 ohm, R4 equals 4 ohm, and R5 is 5 ohms. Okay, so first question is, what is the equivalent resistance between A and B, right? So between these 2 points. Second question is, how much current will flow through each resistor when terminals A and B are connected to a 12-volt source? And the last question is, what is the power dissipated through each resistor? Okay, let's get started with part A. So R1 and R5 are connected in series, right? So then the net resistance of this part of the circuit is going to be just R1 plus R5. So we're going to denote the net resistance, this net resistance as R sub 1 5, which is equals to R1 plus R5, or 1 plus 5 ohms equals 6 ohms. Now, this gray network is parallel with R3 between these two junctions highlighted in green. So we're going to use the formula for the resistors connected in parallel. And what is it? So the net resistance is found by taking its reciprocal and setting it equal to the sum of the reciprocals of individual resistances. So in here it's going to be 1 over R sub 315 is going to be equal to 1 over R3 plus 1 over R sub 15, which has to be equal to 1 over 3 ohms, because it's given here, and plus 1 over 6 ohms, which we found here, which is equals to 1 over 2 ohms. So R sub 315 has to be equal to 2 ohms. Now, this green network is in series with R4, right? So how do you find the resistance of this part of the network? Well, again, we're going to use a formula for the resistors connected in series. So R sub 3154 has to be equal to R sub 315, which is this green network, plus R sub 4. So it has to be equal to 2 ohms, which you found here, plus 4 ohms for R sub 4, which is given here. And this orange network has to be equal to 6 ohms. Now, if you look at this orange network, we notice that it is in parallel with R2 here, right? Between these 2 points, which we denote by open blue circles. Then the total resistance between points A and B is going to be equal to 1.5 ohm, again using the formula for the resistors connected in parallel. I hope this is clear, right? So what we did, we identified that these resistors are in series. We calculate net resistance here. Then we identify that this gray region, gray network, is in parallel with R3, and we calculate the net resistance of this network. Then we identify that these guys are in series with R4, and we calculate the resistance of this network. And this whole orange region of the network is in parallel with R2, and we calculate the resistance of entire network to be 1.5 ohms. Okay, now let's shift to part B of the question. So how much current will flow through each resistor when terminals A, B are connected to a 12-volt source? Well, let's connect it to a 12-volt source, as shown here in this figure, right? So net current flowing through a battery, or net current between points A and B, can be denoted as I sub A and B. What happens to current that leaves a battery and reaches this junction point? Well, it will split into two different parts, right? The one that's going to go through this part of the network and the one that's going to go through a resistor 2. So we're going to denote them I sub 3154 and I sub 2. And what's going to happen to this current when it reaches this part of the network? Well, it's going to again split into two. Current is going to go through R3, and the current is going to go through R1 and R5. And what happens at this junction? Well, at this junction, current from here, and current from here will all come and combine to give us back our current I sub AB, right, which then goes into the battery. Okay, so let's calculate net current. So we know the net voltage is 12 volts. Net resistance is 1.5 ohms, which we found earlier, right? We can find the net current. So we're going to use the Ohm's law. So from here, we can easily calculate I sub A to be 8 ohms by substituting 12 volts for the total resistance and 1.5 ohms for the 12 volts for the total voltage and 1.5 ohms for the total resistance. So the total current that goes through the battery is 8 amps. Now, what we're gonna do, we're gonna try to calculate currents I sub 3154 and I sub 2. Well, since in this region R2 is parallel to this whole network, the voltage, the total voltage here, the total voltage has to be equal to the voltage drop here, because it's these resistors are connected in parallel. So what I'm going to write down is total voltage is equal to V sub 2, the voltage drop across the resistor 2, which is also equal to voltage drop across this part of the network, V sub 3154. So 12 volts have to be equal to I2 times R2, which is 2 ohms, or it also has to be equal to I sub 3154 times 6 ohms. Well, from here we can easily calculate I2 to be 6 amps and I sub 3154 to be 2 amps, right? Because 6 times I has to be equal to 12, so this is 2 amps. Well, I sub 345 is also I4, right? Because the current that goes through this network is the same as the current that goes through the resistor 4. So I4 has to be equal to 2 amps. So we already found current through 2 of the resistors. So let's continue and find the current through the rest of the resistors. Okay, so what happens at this junction? Well, at this junction, we know that, first of all, current I sub 3154 splits into I3 and I sub 15, right? So some of these currents have to be equal to the I sub 3154. Also, this part of the network is parallel to this part of the network. Since the voltage drop across the resistors that are connected in parallel is the same, we can write down V3 has to be equal to V sub 15. Now, V3 is going to be I3 times R3, which is 3 ohms, and I15 times 6 ohms. Remember, we found I sub 15 earlier, which is just sum of these two resistances. 1 ohm plus 5 ohm, which gives us 6 ohms. And I sub 3 plus I sub 15 has to be equal to 2 ohms, which we found here earlier. Okay, from here I just note that I3 has to be equal to twice the value of I sub 1, 5, right? We cancel out 3 ohms from both sides, so you have here you're left with 2 I sub 1, 5. And I just copy this part of the equation. And what do I note? I have two unknowns, I sub 3 and I sub 1, 5, and I will have two equations, this equation and this equation. Well, then I have to solve the system of equations. Well, if I take I sub 3 here, and instead of that I sub twice the I sub 1, 5, because I sub 3 is equal to 2 times I sub 1, 5, then I have 3 I sub 1, 5 has to be equal to 2 amps, or I sub 1, 5 has to be equal to 2 over 3 amps. If this is 3 amps, then I sub 3 is going to be twice that value. It's going to be 4 over 3 amps. Note that I sub 1, 5, the current that goes through this part of the circuit is the same as the current that goes through resistor 1, which is I1, and it's the same as the current that goes through the resistor 5. So I sub 1 and I sub 5 has to be equal to 2 over 3 amps each. So we found all the currents that go through each of the resistors. Okay, so I sub 1 is 2 over 3 amps, I sub 2 is 6 amps, I sub 3 is where did you find? I sub 3 is 4 over 3 amps, and then I sub 4 is 2 amps, and I sub 5 is 2 over 3 amps. So we have all the currents. Now let's look at the last part of the question. So in part C, we have to find the power dissipated through each of the resistors. Well, what is the power? How do we calculate the power? So let's just start calculating by power dissipated through the resistor R1. Well, equation for power dissipated when current I goes through a resistor is just I squared times R. So I already calculated I1, which is 2 over 3 amps, and I know the R1 resistors is 1 ohm, so the power dissipated here is going to be 4 over 9 watts. Power dissipated through resistor 2, 3, and 4 can be found in a similar fashion because we already calculated the values of the currents that's going through each of the resistors, right? And we know the value of each of the resistances. So these are the values for the power for all of the 5 resistors. So we are done with the question, but let's take a minute and discuss how these individual powers relate to the power dissipated through entire network. Okay, so I know that the total voltage is 12 volts. I know the total resistance is 1.5 ohms, and we also calculated the current to be 8 amps, right? The current between A and B. So if I want to calculate the power dissipated through this entire network, it's just going to be net current, total current squared times total resistance, which is 8 squared times 1.5 ohms, or it gives me 96 watts. Now, I also can calculate this power by just adding up these things. So when you're calculating power, it doesn't really matter whether things are in series or in parallel. Power dissipated through here, or heat generated by this resistance, by this resistor, this resistor, this and this resistors, can all be added up to find the net power dissipated. So let's check. Let's see what happens if we add up all these powers. Well, if we add up P1, P2, P3, P4, and P5, we indeed get 96 watts. So we really didn't take into account whether these resistors are connected in parallel or in series. We did this when we were calculating their respective currents and net resistances, but when we're calculating the power, if we know individual power dissipated through individual resistors, we can just sum them up and get net power. Or you can find it the other way by calculating the net power using this equation where you calculate the net current and the net resistance and use the I squared times R formula to get the 96 watts, which is the same as adding them up. Hope this is clear for everyone, and this is it for this question. Thank you.